And I will show you a snippet from the AI game, and then I will explain the technology behind it. So in this video, what you can see is there is player character, that's the one in the middle, and there is on the left there is a character that's NPC or agent, and he's a Zeus, like Zeus the god. So he basically believes he's Zeus, he behaves like Zeus, he's Zeus. And in the on the right side, you can see a free-form dialogue. So we are talking with this agent. It's not prescripted. We just can say whatever we want, and the AI replies with whatever makes sense. And now we actually upset the Zeus because we told him that he's loser and we will not do what he wants. So he decided to kill us. And this entire thing was produced by the AI, except the last part, the animation, obviously. And I will explain how the technology works. So behind this is what we call large language models, which are huge neural networks that were trained on internet scale text corpuses, or a lot of text. So basically what they can do is they can predict the text, or they can do something like autocomplete. That's basically what they do. But because they were really trained on huge amounts of data, they can finish books, you know, they can emulate what the people would do in those books. And so, like some time ago, we figured out that let's use this idea, this technology for our purposes. And how it works is that you can see it on the diagram on the right side. What we do, basically, every time we interact with the language model, we put together a text description of the character's personality, his observations, you know, like what is around, then some event log, things that happened in the past, a dialogue, or the memory of the dialogues, and also previous thoughts of the agents are possible. We then feed this to this large language model, and the large language model does the prediction of like how this story would evolve, you know, like few steps, like few sentences and so on. This is the response, that's the orange one, that's character's response, which are the actions or dialogue or thoughts of the agent. And then we need to parse it, obviously, because we need to convert it to possible actions, the actions that are possible in the game. Because sometimes the language model can emulate something that is not possible to visualize in our game. And so this is basically the trick, and I will stop here for a second, and because I really need to make sure that you understand this, like how this works. So is there somebody who didn't understand, or should I explain again? Okay, seems that everybody understands, but still I will try to explain again, because in normal, the usual traditional AI in games, what we do is that we'll call some behavioral trees or some planners or some scripts, you know, and something like that, and they basically make the agent do some actions or, you know, do dialogues and things like that. In this case, it's really the blue part in the middle that is the brain, and that emulates how people behave, and it works only in text domain, but it's rich and powerful quite enough. So we need to convert the game description and character and all these things to the text, provide it to language model, get the prediction, and then take this prediction and map it to possible game actions.